Here we are with scientific notation, addition and subtraction, and later on this we'll do multiplication as well. Let's start off with a nice little problem. 2.8 times 10 to the 7th plus 3.4 times 10 to the 7th. Now as you look at these things, you realize that when we first started doing addition, we had to always add like things, so we had to line up the decimals. Well, this looks pretty good, but watch what happens when we expand it out to normal decimal notation. We have 2, 8, 1, 2, 3, 4, 5, 6 zeros, right? That's 7 places. Plus 3, 4, 1, 2, 3, 4, 5, 6 places. Yeah, this 7 just simply means the decimal is 7 places that way. So as long as these are like things, the decimals are lined up right. So let's just add them. 8 plus 4 is 12. Carry the 1. 1 plus 2 plus 3 is 6. 6.2. And then the decimal's really 7 places over, times 10 to the 7th. Again, as long as these are like things, then we have the decimals lining up exactly as we need to. So let's look at something where it isn't exactly alike. 3.84 times 10 to the 7th plus 1.43 times 10 to the 8th. Now you notice this is bad. If we expand these guys out, that 3 and that 1 are not put on top of each other anymore. And so we've got to do some adjusting if we're going to add stuff in scientific notation. So let's take a look at a number that we can change piece at a time. Let's look over here. Oh yes, look at this. We have how to change numbers into scientific notation one piece at a time. Now normally you take 238,000, just move it, hey, 5 places over to right here and we're good. Well, let's do it just stage at a time. This number is the exact same as this one, 23,800 times 10. Just added a 0, and hey, you'll get the right number. This times 10 squared. This times 10 cubed, this times 10 to the 4th, these are all equal to 238,000. When you keep doing it such that this number right down there, the number in the front, is at least 1 but is less than 10, then that's official scientific notation. That's where it is. But you can make this change back and forth as much as you want to in the middle of a problem. And so this is what's going on. You'll notice this is our rule. Every time we move the decimal to the left one, have made this number smaller, we have to go up in the power of 10 to compensate for it. So moving the decimal left makes something smaller by 10, and so we have to compensate by putting an extra decimal there. Good, so let's come back here and do this problem. Notice we can't add if they're not like, but we do know that if we go left here, that's left, and this goes up, we have a brand new problem. Moving it over there, we get 0.384 times 10 to the 8th plus 1.43 times 10 to the 8th. And now we notice we have exactly like things. The decimals are both 8 places that direction, and they've lined up correctly. That's a 4. 8 plus 3 is 11. Carry the 1. 8, 1. 1.814 times 10 to the 8th, and these will stay exactly the same. And there we have it. Let's do one more. Subtraction will do the exact same thing, but let's make sure and write that out so it looks nice. And you can do it. 5.6 times 10 to the negative 13 minus 2.3 times 10 to the negative 12. Oh, very interesting. They're not the same, so we can't subtract these right now. Let's do the same thing we did before. Make this go up 1 by making this go left. Negative 13 up 1 will give us a negative 12. So we really have here 0.56 times 10 to the negative 12 minus 2.3 times 10 to the negative 12. Now we realize, oh shoot, we don't even have the biggest one on top. We got to subtract with the biggest one on top and the smaller one on the bottom. So let's rewrite this one more time as negative 2.3 times 10 to the negative 12 and a 0.56 times 10 to the negative 12. All right, now let's do the problem. So this is 2.30. So 0 minus 6 can't do that. That's a 2. 10 minus 6 is 4. 2 minus 5 can't do that. 1. 12 minus 5 is 7. 1 minus 0 is 1. 1.74 times 10 to the negative 12th. And so subtraction, you still have to worry about making sure you have the biggest one on top and do the subtraction, and the strongest one wins. Oh, I almost forgot that. So negative 1.74 times 10 to the negative 12th. And that gives you addition and subtraction. Okay, now let's do multiplication. The one thing about multiplication that happened in fractions and decimals already, we have to remember, we don't need like things. Okay, that's crucial. We don't need to have like things. We don't have to have them have the same exponent or anything like that. So let's do a problem here. 2 times 10 to the 15th times 3 times 10 to the 4th. Notice we don't need them at all the same, but let's see what happens. This number is really 2 with 15 zeros behind it. And this one is 3 with 4 zeros behind it. And when we times them together, we get 6 with, oh my word, 19 zeros. Whew, that's a long one. Look at that thing. That's big. And we end up with 6 with, oh my goodness, 19 zeros behind it. And this gives us the key factor in multiplication. These are just measuring powers of 10. So it will always add to give us this exponent down here. So there we have the rule. Times these guys like normal, add these guys together, and we're good. Let's look at another example, make sure we can do this. 5.8 times 10 to the negative 13 times 3.1 times 10 to the negative 6. All right, let's multiply these guys just like normal and see what we get. 1 times 8 is 8. 1 times 5 is 5. Oh, that was easy. This one, we put a 0 here. 3 times 8 is 24. Carry the 2. 3 times 5 is 15. Plus 2 is 17. Add and we get 8. 5 plus 4 is 9. And 17. So the decimal goes, there are 2 decimal places up here, so we have 2 decimal places right there. 17.98 times 10 to the negative 19 is what it looks like. Yes, indeed. However, caution, you are not yet in scientific notation. This one is the right number, but it's not official scientific notation. It's not simplified, so to speak. So let's pull back what we looked at on how to change it. Our rule was that if you go left with the decimal, you can go up a power of 10, and that will give you the same number. So this is the right answer, but we need to change it. So we need to go left right here and up 1. Left, up. We'll keep the exact same number. So we get 1.798. Oh, look, now that number's between 1 and 10, just like official scientific notation, times 10 to the negative. Negative 19 plus 1 is negative 18 power. And there we go.